In this video, we're just going to revise atomic structure and electronic structure. So we're going to start with looking at the structure of an atom. So you can see I've got a picture here that shows you what an atom would look like. In the middle we've got our protons and neutrons, and we say that they are contained in the nucleus. Then around the outside on these rings I've drawn, we have electrons, and we say that they are found in shells around the nucleus. So you need to make sure that you know the relative masses of these subatomic particles and their relative charge. So a proton has got a relative mass of 1 and a charge of +1. A neutron's got a relative mass of 1 and no charge, it's neutral. Neutrons are neutral. Electrons are really tiny, so their relative mass is 0.0005, but their charge is -1. Now when you look on the periodic table, you'll see that each symbol has got 2 numbers next to it. So the bottom number, that's our atomic number. That tells you the number of protons that that element has in it. And it's usually equal, well, it is equal to the number of electrons in an atom. When you start looking at ions, it won't always be equal. And then at the top, you've got the number of protons plus neutrons. So to work out the number of neutrons, you want to do this big number, take away this small number. So in the case of lithium, we can see the bottom number is 3. And that tells us we've got 3 protons and also 3 electrons. We then want to do 7, take away 3 to get the number of neutrons. So in this case, that is 4. If we look at nitrogen, the bottom number here, our atomic number is 7. So we've got 7 protons and 7 electrons. And then if we do 14, take away 7, we'll get our number of neutrons, which is also in this case 7. Our last example for this is neon, which is one of the noble gases. It's in group 8, or sometimes you'll hear it called group 0. We've got a 20 and a 10. So the 10 is our atomic number. So we've got 10 protons and 10 electrons. And then 20 take away 10 will give us the number of neutrons. So that is 10. You've probably also looked at isotopes. An isotope is an atom of the same element. So it's got the same number of protons, which means it's got the same atomic number, but a different number of neutrons. So it'll have a different relative atomic mass. Isotopes have got identical chemical properties, and that's because they've got the same number of electrons in their outside shell, but they can and they do have different physical properties. So if we look at isotopes, I'll show you an example here. So carbon's quite a common one. You'll hear people talk about carbon-12 quite a lot. So all of these carbons, they're all 6 on the bottom. The atomic number is 6. They've all got the same number of protons, and that means they're the same element, but you can see their mass number at the top is different. Okay, so they've got a different number of neutrons. So they've all got 6 protons, so we can fill that bit in, and they'll all have 6 electrons. Now to work out the number of neutrons, we're doing exactly what we did before. The top number, take away the bottom number. So 12 take away 6 is 6, 13 take away 6 is 7, and 14 take away 6 is 8. Now, electronic structures, or sometimes you'll hear it called electron configuration, is how we arrange the electrons in their shells. So if we just pop back to this picture we had at the beginning of the atomic structure, you can see I've put 2 electrons on this shell and 1 on this shell, and that wasn't just by chance. There are some rules we need to follow. So we start filling up from the inside shell. That first shell can fit up to 2 electrons. The next shell can take up to 8. The third shell can take up to 8, and then the fourth shell can take up to 18. And you'll see these electron configurations written with dots in between. So this is the number of electrons in the first shell, second shell, third shell, and so on. Okay, so this is what we need to learn and remember: 2, 8, 8, 18. So if we have a look at lithium, it's got a 7 and a 3. So we want to look at the bottom number to get our number of electrons. So we've got 3 electrons here, and we tend to show them as little crosses. So I'm going to pop 2 on my inside shell, because that shell could fit up to 2. That only leaves me with 1 more. So that's going to go on the next shell. So my electron configuration there will be 2, 1. Okay. The next one we're going to do is nitrogen. So you can see we've got 7 electrons there because the atomic number is 7. So still only 2 fit on the inside shell. And then we've got 5 left over, so they need to go in the outside shell. 2, 3, 4, 5. Okay, and you'll see they're often drawn in pairs, and we'll come to that in another video. And then we've got potassium. So it's got 19 electrons because its atomic number is 19. So we're going to have 2, and then 8, because that's how many fit in that shell, which means we've used up 10 so far, so we've got another 9 to use up. So we'll pop 8 in this next shell. And then that only leaves us with one more, so that will go on the outside shell there. So the electronic configuration for potassium is 2, 8, 8, 1. And you can check that that's right because those numbers should add up to 19, which they do. Now, you can use the periodic table to help you out in exam questions. Sometimes they ask you which group something is in and they'll give you a diagram. The group number, so the groups are the columns on the periodic table, that will tell you how many electrons there are in the outside shell. Okay, so if it's in group 1, it's got 1 electron in its outside shell. Group 2 has got 2 electrons, and so on. The period, they're the rows that go across, that tells you how many electron shells there are. So if we look at lithium, I'll just show you my periodic table here. Lithium is in group 1 and it's in period 2. Period 1 only includes hydrogen and helium. Okay, quite often people get that wrong. So lithium is in group 1, period 2. And so what that tells us is it's got 1 outer electron and it's got 2 electron shells. Okay, now we know that because its electron configuration earlier was 2, 1. Okay, so it's got 1 electron in its outside shell because it's in group 1. It's got 2 shells of electrons because it's in period 2. If we look at nitrogen, you'll see nitrogen is in group 5 and it's also in period 2. Now nitrogen had 7 electrons and they were arranged 2, 5. So that 2 is the 2 and the 5 tell us we've got 2 electron shells, so it's in period 2. And it's group 5, so we've got 5 electrons in the outside shell. Potassium is in group 1, period 4, and you can check this against a periodic table. So we had 2, 8, 8, 1. So you can see there, period 4, we've got 4 electron shells. 1, 2, 3, 4. Group 1, we've got 1 electron in our outside shell. So we'll just do one more example. Phosphorus is number 15 on the periodic table. So if I just show you where it is on the periodic table, it's here. So it's in group 5 and it's in period 1, 2, 3. So we would expect it to have 3 electron shells and 5 electrons on its outside shell. So we've got 15 electrons to use. So we'll pop 2 on the middle and then 8. So we've used up 2 and 8, we've used up 10 so far, so we've got 5 left over. So they're going to go in our outside shell. And our electron configuration is going to be 2, 8, 5. Okay, so it's got 3 electron shells and it's in period 3. It's got 5 electrons on its outside shell and it's in group 5.